Hi everyone and welcome back to my channel. I'm Shivali and you're watching Swiftly Shivali, a place for developers to learn, grow, and make an impact on their careers. And today we're talking about automatic reference counting, retain cycles, and weak versus strong references. There's a lot on the agenda today, so let's jump right in. I'm going to start off by introducing the concept of ARC or automatic reference counting, which Swift uses to track and manage your app's memory. So this is great because in most cases, you don't even need to think about memory management by yourself. ARC will automatically free up the memory used by class instances when they're no longer needed. So I've created two classes here for today's example. And it kind of goes along with the theme of travel. One is a person class and one is a bag class. If you've stuck around with my channel for some time, you will know that I love to travel and a lot of my videos use a similar example. So over here I have a person who is going to be traveling. We have a name variable over here, which is of type string, and then we have an optional bag variable here. In the initializer, we have those two fields, name and bag, and the bag variable is optional because we may or may not be traveling light. So I could be traveling without a bag, and in that case, then the bag field would be nil. Then I also have the dinit function here, which is called whenever the class is deallocated. So over here, I have a print statement just so we can use it in the example, and I have this name is being deinitialized. And that way we can track when ARC is working and when ARC is preventing our class from becoming deinitialized. So in the next class, I have the bag. And the bag also has a passenger associated with it, which is of type person, the class that we just created above here. And it also has an ID so that the airlines company can track it properly. And the ID is required, and the person is optional right now because, we may or may not be traveling with this person. And then we have a init function here, and again it's printed, so the bag with this ID is being deinitialized. So every time a new instance of a class is created, ARC allocates some memory to store this info in. And so let's go ahead and create an instance of one of the classes. So I'll just create an instance of the person class of myself, so variable Shivali, and we'll make it of type person, optional, and create it here. And we'll call the initializer the string, and right now, let's just say I am traveling very light, I don't have a bag, and we can assign a bag later whenever I want to take it. So over here, when an object is no longer needed, we will see that ARC will deallocate memory from it. So one example of that would just be if I set this variable equal to nil. So we'll see that ARC will work, and in the console here, our print statement has been printed out. So that's very simple. However, if ARC were to deallocate an instance that was still in use, we would have a big issue and our app would crash. So ARC is very smart about this, and it makes sure that your class instances don't just disappear when they're still in use. So let's see an example of this. So over here, I have my person variable, but then I'll create a bag variable. Again, I'll call its initializer, and let's for now just have it decoupled from a person, Suppose it's like sitting in my closet, I haven't decided to take it yet, and then over here I have it like that, and then later I decide, okay, I want to take this bag with me. I'm just going to go ahead and say bag dot passenger equals Shivali, and then I try and de-initialize Shivali, and I see that nothing gets printed out in my console. So as you can see, the de-init function was never called, and our print statement isn't printed out in the console. This is because every time you assign a class or instance to a property, constant, or variable, that property, constant, or variable creates a strong reference with the other class. And ARC will not allow that object to become deinitialized when a strong reference exists. So over here, we have bag has a strong reference to Shivali, and obviously we have one instance of Shivali created here, and so when we try and set this person to nil, ARC will not let us. And this is just a built-in like safety feature so your app doesn't crash. But going back to our example, we have to set the property within our person value too to associate them together. So going back to our example, if I want to tie the bag to this person, I'm going to want to do something like this and use the bag that we had created earlier. But then what this does, it also creates another strong reference from Shivali to bag. And this is not good at all, because what is happening here is we've created a strong reference cycle, and now we will never be able to deallocate either one of these classes, like these two instances. We'll never be able to become decoupled from each other because they both hold strong references to one another, and your app is going to have major performance issues. And that's because we're going to continue to use up memory every time we associate a passenger and a bag together. And the way to fix this is by creating a weak reference, which is the solution to having these strong reference cycles. So a weak reference is a reference that does not keep a strong hold of the instance that it refers to, and so it won't stop ARC from disposing of the referenced instance. This behavior prevents the reference from becoming part of a strong reference cycle, and you simply do this by using the weak keyword before the property or variable. So in this case, it would be this passenger variable that we have here. As soon as we add the weak keyword here, the reference becomes a weak reference, and we can right away see that our print statement is printed out in the debugger when we hit line 44 and we set Shivali equals nil. And so this is important to remember, that an object only gets deinitialized when the automatic reference count in like ARC is equal to 0. And so let's go ahead and count how this worked. So we've created a variable here, Shivali of type person. The count right now is 1 because we reference this person once. Then we come down here and we associate the bag's passenger to be Shivali, and so that again is another reference to this instance of the class. So that goes up to 2, and then setting Shivali to nil, so that's a -1. And so right now we still have one active reference to Shivali, and if this variable was not weak, then we would have a major problem. But now that the variable is weak, it's okay that ARC is is going to deallocate the class, even though the reference count is not 0. So the reference count is 1, but because this one reference is a weak reference, it's okay. And there you have it. This video sums up like an introduction to automatic reference counting in Swift, along with weak versus strong references. And if this video was useful to you, please don't forget to subscribe to my channel. It really motivates me to create content for all of y'all. Also, don't forget to follow me on Instagram at SwiftlyShivali. I'll be posting regularly during WWDC, and with that said, see you in the next video.